Hello everyone watching, I am Bryan Chavez and here with me today is Victoria Rodriguez, and today we'll be discussing the topic of SARMs. So let's get started with a little introduction to testosterone. This process begins with cholesterol, and then through an extensive process we end with testosterone. Step 1 of this process is when the oxidation cleavage of the side chain of cholesterol occurs by an enzyme, cholesterol side chain cleavage enzyme, and pregnenolone is left as the product. Step 2 of this process is the removal of some carbon atoms by CYP17A1 enzyme to produce one of two products. In this case, we'll be focusing on 17-alpha-hydroxypregnenolone. Step 3 then, 3-beta-hydroxysteroid dehydrogenase oxidizes the hydroxypregnenolone from the previous step and produces androstenedione. Step 4 of this process is then 17-beta-hydroxysteroid dehydrogenase reduces androstenedione and produces testosterone.
So what does testosterone do?
Well, it may be common knowledge that testosterone, like other steroid hormones, works by binding to the receptors on the cell membrane of specific cells. Specifically with testosterone, we are focusing on androgen receptors. But what might be novel information for some is that after the receptors are activated and testosterone enters the cell cytoplasm, testosterone will bind to another androgen receptor and be reduced to DHT by a 5-alpha reductase. This new form, DHT, will then enter the cell nucleus. Within the cell nucleus, DNA, the DHT will target specific nucleotide sequence denoted as hormone response elements. It will then activate these areas to be essentially brought to action. These areas lead to actions such as muscle building and other male qualities. Let's move on to the next segment. Why does this lead to SARMs?
What are SARMs?
SARM stands for Selective Androgen Receptor Modulators. They are chemicals that cause favorable biological effects to some tissues. Also, SARMs are described as compounds which elicit androgen agonism in one or more target tissues, such as muscle or bone, and antagonism or minimal agonism in other tissues, such as the prostate and skin.
So why were they made?
Nuclear hormone receptors, NHRs, are members of the nuclear receptor gene family that regulate a wide range of physiological effects and are activated through the binding of small ligands, hormones, and act as transcription factors by interaction with distinct DNA motifs on gene promoter to control target gene transcription. After the discovery of the tissue-specific capabilities of some of these molecules, research and time was put towards finding molecules that target many other tissues in the human body, such as muscle cells and androgen receptors. During the production of SARMs, they were constructed in a way as to acquire an agonist of the androgen receptor without the susceptibility of binding to and serving as substrates for aromatase and 5A reductase. Let's move on to the next segment, functions and applications. We are studying the functions and application of SARMs in order to learn more about their role in human exercise, nutrition, and overall physiology.
How do they change the chemistry of the body?
Testosterone serves as an important hormone molecule that controls various physiological properties in humans. During times of a health crisis or aging, testosterone supplies drops below normal and unfavorable muscle loss, and other health problems occur. Testosterone supplementation helps stop this and retain muscle mass and bone health. Therefore, therapeutic agents such as SARMs that can achieve anabolic effects on the skeletal muscle and bone without the dose-limiting adverse effects associated with testosterone would be attractive as a function of promoting anabolic therapies.
The next segment is SARMs functions in the human body.
Can there be side effects? Why are they different from anabolic steroids?
The side effects of SARMs do tend to be of less severity than the anabolic steroids. This is because they are not easily converted to 5A reductase, an enzyme involved in androgen and estrogen metabolism. This enzyme converts testosterone into DHT, an androgen sex steroid and hormone. DHT is the reason for all of the unwanted side effects of steroids, and therefore, since SARMs do not produce the 5A reductase, there are very few side effects that are caused by them. However, that is not to say that SARMs are safe. They have not been thoroughly researched and have only been present for a few decades, so the long-term effects are not yet known. Now we're going to talk about MK2866.
What is MK2866?
It is also known as ostarine and is one of the most studied SARMs, with research that provide results that show minimal side effects and efficiency to build muscle. The importance of these studies is that they show that there were no significant side effects, and in one case, there was a net gain of 3 pounds of muscle in a month with no exercise done. The people who took it in high doses, however, reported testosterone suppression. Now we're going to discuss MK677.
What is MK677?
It is also known as Ibutamoren and is not very thoroughly researched. The research that has been done, however, supports its ability to increase growth hormone and IGF levels. It may be an important medicinal steroid when more thoroughly researched because while increasing growth hormone levels, it does not increase any other hormone levels, thereby reducing health risks. Ibutamoren helps build muscle, reduces muscle wasting, improves sleep, increases bone density, combats aging and increased longevity, has nootropic effects, and has benefits in treating growth hormone deficiency. Now we're going to move on to the abuse and regulations of SARMs.
Are they legal?
Yes, you can buy SARMs over the counter and they are completely legal. This is because they are sold as experimental chemicals, which retailers use as a legal loophole since they are not technically made for human consumption.
What about in sports?
They are not permitted in sports, and there are multiple agencies and committees who are working to ban and detect them. SARMs may one day be banned altogether since they are really just steroids with the same positive effects, despite the lowered amount of negative side effects.
Lastly, let's discuss the significance of SARMs to muscle growth.
What are SARMs' role in exercise?
They lead to an increase in testosterone, which leads to an increase in lean body mass and muscle functions. An increase in bone density is also noted. Muscle mass, muscle function, and bone density are favored when pertaining to exercise because they are the main components of the human body that are utilized during strenuous activity.
And what are SARMs' role in nutrition?
An increase in testosterone also leads to an increased BMR. Increased BMR means that more calories are needed to meet the basic nutrition needs of the human body at a given age, weight, and gender. SARMs are shown to increase the effects of testosterone, which includes testosterone's effect on human metabolism.
To summarize, SARMs are still in an experimental state, and the long-term side effects are still unknown. Though they do show less side effects than steroids, through the research we have done, we can conclude that more time and research is needed to prove that SARMs are safe for regular use in exercise, nutrition, and overall physiology.